Do you know when to? Do you like the things that life is showing you? Where are you going to? Do you know? We ain't going anywhere. Hello, everyone, and welcome back to another episode, another moment in time that you're going to share with Mrs. Audrey Codner-Gibson from ACG Math Tutoring. Whoop, whoop. All right, so we're working on those algebraic skills. Try to get that little pre-algebra. Try to get that algebra 1, maybe a little bit of an algebra 2. So we're trying to get those skills so we can get up and moving. So enough of me telling you what we're going to do. Get ready to do it. Okay, everyone, welcome back. Are you ready for me? Are you ready to get this done? Because guess what? I'm ready to teach you. I know, crazy. So, like we always do, let me share my screen with you. And we got my cute little kitty cats. Oh, just make it so sweet. So we're working on graphing linear equations. So what we did before, we solved one step, we solved two step, we looked at that distributive property, we did a little bit of the multi-step, just a little bit, just a smidge. And now we're gonna look at linear equations on a graph. So some of you guys are probably like, I don't like graph. It's a pandemic, girl. I don't got no graph paper. I might just make it work, okay? Just try to do the best you can. But looking at the graphing of linear equations, we're looking at those Common Core standards. So AREI 0.3 and AREI 0.10. So we're looking at solving and we're looking at graphing at the same time. All right, so we're going to review what we did last time. So we're looking at that whole distributive property and solving for our variable. So for number 1, we have 7 times x plus 1 equals 5 times x minus 3. So, like we said before, anytime you have those parentheses, we want to get that distributive property going. So for the first one, we're going to distribute 7 to everything in its own parentheses. So that's that x plus 1. So that means we have 7x plus 7. Bring down the equal sign. So now we're going to distribute the 5 to everything in its parentheses. So 5 times x gives me 5x minus 15. So if you recall, when we have a variable on both sides of the equal sign, we need to make a decision. Is it going to be on the left side or is it going to be on the right side? So I know a lot of people say put it on the left, so I'm going to put it on the left. So that means this 5x needs to come over to the other side, equal sign. So in order for me to do that, I have to do the inverse, which is negative 5x. So that means 5x minus 5x gives me 0x. But remember, 0 is a placeholder in this case because we still have this negative 15 left over there. So everything comes down. And then we're going to combine this 7 minus 5, which gives me 2x. So now we want to solve for x. We want to isolate that variable. So we have a plus 7. So the inverse of plus 7 is minus 7. So 7 minus 7 gives me 0, and we don't need a placeholder because we still have that 2x that needs to come down. So then we have negative 15 minus 7. So since they're both the same sign, I'm going to bring down the negative, and I'm really adding, which gives me 22. So now 2x, since there's not a plus or minus in between the 2 and x, we're going to divide. This is multiplication, so we're going to divide it. That's that inverse. So we divide both sides by the 2 because we want to isolate that x. And then we have negative 21 divided by 2. A negative divided by a positive gives me a negative. Okay, and 22 divided by 2 gives me 11. So for the first one, my first answer is negative 11. So for number 2, we have this fraction. 5x minus 4 divided by 2 equals 18. So anytime you see a fraction, that means division. What's the inverse of division? Multiplication. So you always multiply by whatever's in the denominator, which is 2. So it's the same. 2 divided by 2 gives me 1. And since I have this 5x minus 4 to bring down, I don't have to worry about that 1. Because if I multiply this expression by 1, it's going to give me the same thing over again. So now we got 18 times 2, which gives me 36. So now I'm solving for x. So I need to get rid of that minus 4, okay? So 5 and x stays together. That negative 4 needs to go, all right? So we're going to add 4 on both sides. So negative 4 plus 4 cancels and gives me 0. Remember, we don't have to write the 0 because we have that 5x to bring down. So now 36 plus 4, that gives me 40. Okay? So now 5x equals 40. So that means I need to divide both sides by 5. And then x will equal 40 divided by 5 will give me 8. So for your previous exit ticket, if you got negative 11 and a positive 8, let me tell you, you're doing good. If you didn't, if it was like, oh, I forgot about changing the signs, I subtracted 4 instead of added 4. But the fact that you see it and you're like, oh, that's what happened. If you can self-correct, that's also a room for improvement as well. So I'm going to give you thumbs up for that. All right, because you know what, you're doing it. So let's get with today's target and today's agenda. So you should be saying to yourself, I can graph linear equations in a coordinate plane. And if you remember a coordinate plane, it was those two number lines that's intersecting at one point called the origin, okay? So we talked about those, all right? So we already reviewed the exit ticket. We're gonna look at some guided notes. We're gonna do some practice, and then we're gonna close out with another exit ticket. So when you're looking at graphing linear equations, so the graph of a linear equation is always a straight line, hence the word linear. If you notice, inside it has that word line. So anything that's going to be a linear equation, it will always graph out to be a straight line, all right? Like if I use my pen, this is a straight line. It goes this way, this way, this way, or this way, okay? So there's going to be two variables going on. So before, when we did our solving, we only had like one variable. We had an x, we had a y, we had an m, we had a c, we had almost every letter in the alphabet except for E and I. We'll explain that later, okay? But there's going to be two variables, and each of those variables is going to be a power of 1. So the variables we're going to use is x and y. So there's different forms of representing a linear equation. The one that we're going to look at is called the standard form. So the standard form writes out as this: ax plus by equals c. So the letters A, B, and C, they're representing those integers. They're representing those positive numbers, those negative numbers, those also 0, okay? But the key thing is your A, as I like to call my leading coefficient, because it's the first letter of the alphabet, it's always in front, that cannot equal 0. It can equal a negative number, it could equal a positive number, but it can't equal 0, okay? Because that's the lead, that's the beginning of it all, okay? We have to have an x represented, we have to have a y represented when we do these equations, okay? So a linear equation has an infinite number of solutions. So if you notice on my graph, I have a green line, okay? And I have 1, 2, 3 points designated. But guess what? On that line, there is infinitely many solutions. There's tons of solutions going this way, and there's tons of solutions going that way, okay? So you have so many different points that is covered in that line, that makes up that line, all right? So, helpful hint, okay? You want to select 4 values for x. You can use any value you want. Normally, I like to do a couple, negative, a 0, and a positive number, okay? Sometimes this is my standby, -2, -1, 0, 1. Sometimes it's -1, 0, 1, and 2, okay? I have to look at the situation because sometimes in situations I might have to say -4, -2, 0, and 2, okay? It all depends on the situations, but usually this first one right here, that's my go-to, okay? Now, what you're going to do is you're going to take those values of x and you're going to substitute it into the original equation in order for you to find the y value, okay? And once you find those things, once you find, you know your x, you know your y, what you created was what's called an order pair or a coordinate, okay, that we can use to plot to create a graph. Once we plot those points, once we plot those coordinates, once we plot those order pairs, we're going to connect them with a line, all right? So breathe and just observe, all right? So we have our first examples. We have y equals x plus 3. So what I like to do is to write these things out and show you in a table. So I'm going to show you step by step. If you feel like, all right, I know how to do this, I can just kind of brush on through, go ahead, brush on through. But right now, I really want to take it step by step, all right? So let me get myself out the way. I'm going to write my equation here. I'm going to have my x values here. I'm going to have my y values here. So my x values, that's also known as my input, because I'm putting these values into the equation. Input in the equation, okay? So what I get out of it is called my output. I know, it's so deep, right? It goes in, it's your input. It comes out, it's your output. Who knew? So easy, right? So remember what I said, I like to go my go-to. So I like my -2, I like my -1, I like my 0, and I like my 1, okay? These are my standards. When they say find points, I like to use these, okay? So what I'm going to do, I am going to substitute this -2 in for the x. So I got -2 plus 3, okay? I'm going to substitute for the next one, the -1 for the x. So I got -1 plus 3. Hopefully you're seeing what I'm doing. All I'm doing is replacing the x values, the x with these values. All right? So the answer to this is going to go into the y column. It'll be my output. So I have -2 plus 3. So both signs are opposite. That means I'm subtracting. And then I'm going to take the sign of my largest value, which is 3. So I'm going to subtract. What's 3 minus 2? That gives me 1. So now I got -1 plus 3. Again, both signs are opposite. I'm taking the sign of my larger one and I'm going to subtract. What's 3 minus 1? That gives me 2. Now I got 0 plus 3, which gives me 3. And I have 1 plus 3, which gives me 4. What you just created are going to be called order pairs, or points, or coordinates, whichever you want to put. What you do is you take your x value, which is a -2, and then you put your y value, in this case is 1. So this is going to be a point that we're going to plot on our graph. So if I go with the next one, we have -1, and I got my result of 2. For the next one, we got 0 and 3. For the next one, we got 1 and 4. Okay, so these are going to be the order pairs that I'm going to plot on my graph. So if you recall, remember what we did with the coordinate plane? We always start at the origin at 0, 0. So for the first one at -2, 1, that means I'm going to the left 2, and I'm going to go up 1 and plot my point. So for the next one, starting at 0, I go to -1 and up 2. Next one is 0, so I just go up 3. Next one is 1, 4, so that means I'm going to the right 1 and up 4. And what do you notice? It looks like there's a straight line. I'm going to try to draw a straight line as best I can to go through all these. Now, when you draw your line, you have to put what's called arrowheads. Because what happens is this line is not just going to stop right here. going to continue on all the way to the right to positive infinity and all the way to the left to negative infinity. Okay, so I got to stretch out like this. Okay, so you're only going to see a small snapshot of your graph. So with you extending it out by putting those arrowheads, you're telling whoever's looking at the graph that my graph is going to extend all the way to positive infinity, all the way to negative infinity in this graph. All right, so looking at it, it's going upwards from left to right, it's going up. And I plotted all my points. Guess what? That's how we graph a linear function. All right, I'm going to use a table, which that's what this is called over here. I'm going to have my input, I'm going to have my equation, and I'm going to have my output. So if I wanted to, I could just write the expression. If I wanted to, I could have just wrote x plus 3 and just substitute the numbers in for x. And then when I solve, I know that's going to be in my y columns because it says y equals. All right, let's try another one. So for number 2, we have y equals x over 2, or x divided by 2 minus 1. I can hear you. Like, why is she doing this? Because you need variety. You know, we can't all just eat vanilla ice cream all the time. Sometimes we need cookie and cream, but sometimes we need a little bit of spice to it. Huh? Come on. So we have x over 2 minus 1. So this is that situation when I go with my x values that I like to say -2, -1, 0, and 1's not going to work. The reason why I'm saying that is the numbers that I'm going to use have to be divided by 2. So I could, if I still want some negatives and I want some positives, I could say -4, -2, 0, 2. Okay? The reason why I'm doing this is because I know that they're multiples of 2. So if I divide it, I'll definitely get a whole number. All right? So all I'm doing is I'm going to take the -4, replace that x. I'm going to take my -2, replacing that x. I'm going to take my 0, replacing that x. And I'm going to take 2, replacing that x. Okay? If you want to put parentheses around it just to show the substitution, you can. It's not going to hurt anything, but we're not distributing anything, so it's not really going to be necessary. Okay? So now, order of operations. Please excuse my dear Aunt Sally. Okay? So we don't have any parentheses technically. We don't have any exponents. We're either doing multiplication or division from left to right. So as we can see, we got that fraction, which is representing division. So -4 divided by 2, that will give me -2. And what's -2? Let me write that right here. -2 minus 1, since they're both the same, that's going to give me a -3. Then I got -2 divided by 2, that gives me a -1. So -1 minus 1, that gives me a -2. 0 divided by 2 will give me 0. And 0 minus 1 will give me a -1. And then 2 divided by 2 will give me 1. And 1 minus 1 gives me 0. So the order pairs that we're going to do or plot is -4, -3, -2, -2, 0, -1, and 2, 0. All right? So if we start at 0, 0, start at our origin, we'll go to -4, which is to the left 4, and then I'm going to go down 3. Plot my point. Then -2, -2 to the left 2, then down 2. Plot my point. Then 0, -1, we're already at 0. We just have to go down 1. And lastly, we have 2, 0, so I'm going to the right 2. And since it's 0, I don't have to go up or down. So then we got this. I'm going to try, yeah, that's hideous. Let's see if I can get rid of that. All right, let's try again. Close enough, okay? I'm trying to do it on template here, people. Working on it without a ruler, okay? So as I look at it, reading from left to right, the graph is going upwards. I'm able to plot my point, and it was, if I drew it straight, it would give me a straight line, all right? So, number 3. So we have -2 plus 3x. We got our x, and we got our y. So if we notice, we got by 3. We're not dividing. So usually when you're dividing, that's when you do those special ones. But for me, I'm just going to go right to -2, -1, 0, and 1. So I have -2 plus 3 times -2. Notice the x is more towards the end than the beginning. But that 3, that's still my leading coefficient, okay? Even though things are rearranged, whatever is next to my x, that's going to be my leading coefficient, all right? So we have -2 plus 3 times -1, -2 plus 3 times 0, -2 plus 3 times 1. So all we're doing is substituting these values for my x, okay? It's easy for me to do this. So we got -2 plus 3 times -2 gives me -6. So that's going to give me a -8 because they're both the same sign. So we're adding. So -2 plus 3 times -1, which gives me a -3, and that will give me -5. So -2 plus 3 times 0, which gives me 0, okay? And -2 plus 0 gives me -2. And then -2 plus 3, because 3 times 1 gives me 3, that will give me an answer of 1. So the order pairs this time is -2, -8, -1, -5, 0, -2, and 1, 1. So starting from my origin, going to the left 2, and then I'm going to go down 8. So my point's going to be right here. Then -1, 5, -5. So we're starting -1. Then we go down to -5. Then we have 0, -2. So here's my 0, here's my -2. And 1, 1 will be right there. Okay? And then you can draw your line as best you can, which gives you that straight line. All right? Okay, so now let's go for another practice. I know it says 1. So we have y equals 2x minus 1. So we got our 2x minus 1. We got our x. We have our y. So since it's not division, I don't have to worry about, okay, give me multiples of 2 or multiples of 3 because it's multiplication. So I can go to my -2, -1, 0, and 1, all right? So that means anytime I see an x, I'm going to plug in a -2 for the first one. Then I'm going to plug in a -1 for the next one. Then I plug in a 0 for the next one. And I plug in a 1. So 2 times -2 gives me -4. And -4 minus 1 gives me -5. 2 times -1 gives me -2. -2 minus 1 gives me -3. Okay? 2 times 0 gives me 0. Minus 1 still gives me a -1. And 2 times 1 gives me 2 minus 1, which gives me an answer of 1. So my order pairs is -2, -5. -1, -3, 0, -1, and 1, 1. So starting at the origin, go to the left 2, down 5, plot my point. Go to -1, down -3, plot my point. You got 0, down -1, plot my point. And then you go to the right one and up one, plot my point. So hopefully you're seeing. I'm going to try to draw as straight as I can. So as you can see, a lot of the stuff that we did earlier, plotting points on a coordinate plane, is now being applied when we get more into the algebraic concepts, okay? So it's never like, okay, it's one and done, I'm done that. going to keep moving on. The one thing that I do like about math, it always spirals back. It always takes those basic skills to bring it back into a new way. All right. So hopefully you can say this. My learning target, did we achieve it? Can I graph linear equations on a coordinate plane? Yes, you can. Best way is to use a table, okay? Try to do those t-tables or maybe one of these lovely extension tables so that you can put the expression here. Okay, you got your x value there and your y value there, and you're just doing your substituting. You're plugging in the input, aka the x, and what you get out, the output, aka y, will help you figure out those coordinates so you can plot on this coordinate plane. So I think we did achieve that. All right, we already reviewed. We looked at those guided notes, we looked at examples, and we had one practice. Exit ticket time. Let's do it. Yeah, let's do it. So I'm trying to do it a little bit different this time, okay? Get a little change, a little flair, you know? Like I said, we're not all vanilla. We like a little chocolate chip, you know, a little bit of raspberry swirls into it. So what we're going to do for our exit ticket, you're just going to tell me which graph represents the equation y equals negative x plus 5. So just by looking at it, is it graph A, is it graph B, or is it graph C? So you might have to do a table, figure out where will my coordinates land, and which one has the best representation. All right, so just a little spice of life, just a little bit different. As always, this has been awesome. You're probably like, when she switched? Yeah, my computer was about to die. So I didn't want to lose out on anything. And I definitely wanted to finish this out because I was having kind of fun with this. All right, why break up the family? This is what we got to do. So like always, if you are enjoying this and you want to continue to see these videos, you want to figure out when these videos are going to pop up, please subscribe. Hey, drop a note, drop something. And then you got the notification button. Hit that, okay? Like it, subscribe it, and share it. We need to share this with as many people as we can. All right, I know right now it's a little crazy. I don't even know what day it is because of this whole pandemic. I was just like, oh man, it's Sunday. I gotta put my thing on. So if anything, it's always been a pleasure. I hope to see you soon. So take care of yourselves. Bye.